Hi, in this video I'm discussing a question in electric field based on mathematics. So in this question, at 2 points L and M, 2-point charges are kept, each of them carrying charge of 4 into 10 to the power minus 13 coulomb. O is the center of LM. So the distance between L and M is 0.5 meters. So you know that at point O, both carrying the same magnitude of charges. At O, the electric field strength will be 0. We know that. So along the line OP, the strength of the magnetic field is varying. So at point P, the magnetic field strength is the maximum. So which is at a distance of x from O. The question is, first part, find the value of x from O where the strength of the magnetic field is maximum. Okay, how to answer this question? So I can say like this, at point P, if I draw a diagram here again, so this is O. So if I draw the diagram again like this, at point P, I take an arbitrary point where the electric field strength will be, you know that, how to find the direction of the electric field strength. We assume if I keep a positive test charge at that point, the direction of the electrostatic force acting on the positive test charge indicates the direction of the electric field strength. So these two charges are positive. So this is plus 4 into 10 to the power minus 13 coulomb. So this is also the same magnitude of charge, 4 into 10 to the power minus 13 coulomb. So the electric field strength due to this charge at this point will be along this direction. I can call it as E1. The distance is R. Same way, the electric field strength due to this charge at this point will be along this direction. That also will have the same magnitude because O is the center. P will have the same distance from M and L. We know that the electric field strength is given by E equal KQ over R squared, where both charges have the same magnitude and the distance of MP and LM are the same. Therefore, the electric field strength due to this charge at this point and this charge at this point will be the same, right? So I can say E1, these angles take it theta, this also theta. Okay, so the resultant electric field when we find that will be E1 equal KQ over R squared. So the resultant electric field strength will be, when we resolve it vertically, they will get cancelled. So the resultant electric field strength at that point P is the point where the maximum is occurring. So I can call this point as say S. So at point S, arbitrary I took a point S. The resultant electric field strength will be in this direction because vertical components of these two electric field strengths will cancel each other. So the resultant electric field strength will be towards right. That will be E equal to E1 cos theta, where cos theta is equal to, we know that this distance I can call x, this distance from O I'll call it as x. So cos theta will be x over r, right? X over r. Okay, so I'm going to solve it further, this equation. So along this direction, E is equal to 2E1 cos theta. E1 is equal to KQ over R squared, and also I know that R is R squared. If I use the Pythagoras theorem, R squared is equal to x squared plus, I'll take this distance 0.25 because half of it, O is the center of LM, but I'll replace it by L. If I say this is L, this also L is equal to 0.25 meters. So R squared is equal to L squared plus x squared. I'll substitute L 0.25 later. So I can say equal to E1 cos theta. So instead of E1 I can say 2 times KQ over R squared. Instead of R squared I can put L squared plus x squared times cos theta x over R. So x over, instead of R I should take the square root of it. So that's going to be x over R squared, x squared plus L squared, or L squared plus x squared to the power of half. So that's going to be 2kq times x over L squared plus x squared to the power of 3 by 2. That's the resultant electric field strength at any point along OS. At any point along OS, this is the resultant electric field strength. So that shows that when x equals 0 at O, the resultant electric field strength will be equal to 0. And we know that when x increases, the distance increase. When the distance increases, R will increase. E is inversely proportional to R. So electric field strength again decrease. So we know that the electric field strength will be equal to 0 at O, and it will be 0 again at far distance. So there should be a maximum. So if you sketch a graph, electric field strength against x, we know that when x equals 0, the electric field strength is equal to 0. When x becomes very large, mathematically I can say when x becomes infinite, it will become again 0, here 0. So the graph should have a shape something like this. So there will be a point for x where the electric field strength will be maximum. We need to find that distance. That's the first part question. Okay, so to get the maximum electric field strength, you know in mathematics we need to differentiate, because we know that we got an expression for electric field strength in terms of x. So only E and x are the variables. K is a constant, Q is a constant, L is a constant, L is 0.25. I will substitute later. So electric field strength depends only on x. So I need to differentiate this equation to get the maximum value of electric field strength. Okay, so to get the maximum value of electric field strength, I should differentiate E with respect to x. So you know that at maximum, minima, dE over dx must be equal to 0, but it can't be minimum because we know in terms of numerical value, electric field strength, the minimum is the 0. So it can't be minimum, so it should be maximum. We are going to find it. So dE over dx should be equal to 0. We'll differentiate it. So 2kq, and this should be squared. So we should write L squared plus x squared. 3 by 2, if I square, it will become cube. Write this one, L squared plus x squared. 3 by 2. Dx over dx is equal to 1 minus x into, differentiate this denominator, it will be 3 by 2 L squared plus x squared. 3 by 2 minus 1 is going to be half, so that means square root, into, differentiate inside the function, it's going to be 2x. Should be equal to 0 at maximum. Okay, so here I can divide the whole equation by 2kq and multiply by L squared plus x squared all the cube. So I'm going to get new equation. So I'll get an equation of, if I continue here, L squared plus x squared 3 by 2. So here 2 and 2 will get cancelled. X squared. So 3x squared minus 3x squared times L squared plus x squared half equal 0. Okay, so I can divide the whole equation by L squared plus x squared to the power half. So if I divide it, the whole equation by L squared plus x squared to the power half, that will become L squared plus x squared minus 3x squared equal to 0. That is L squared plus minus 2x squared, or L squared equal 2x squared. So 2x squared is equal to L squared. So L squared means 0.25. L is 0.25, half of it. So 0.25 squared. Find the value of x. You will get a value for x which is equal to 0.17 168 or 177 meters, that is 17.7 centimeter. So that means you will get the maximum value of electric field strength will be obtained at a distance of 17.7 centimeter from O. So this is the answer for the first part. Second part, find the maximum value of the resultant field strength. Okay, you found the distance x at which the maximum electric field strength obtained. So substitute this value in meters in this equation. So I can say second part, E max equal. So I can raise the question now. Okay, so second part, I can find it. E max equal, substitute this value in this equation, 2kq over L square plus x max square, not maximum x, the x belongs to maximum electric field strength, into, or I can say to the power of 3 by 2, into x to the power x max. This equation, 2kq over L square plus x squared, 3 by 2 into x maximum. So we'll find it, E max equal, substitute the value 2 times, k is the Coulomb's constant, 8.99, 10 to the power 9. Q charge is given, that is given as, the value of charge Q is given as 4 into 10 to the power minus 13 Coulomb times x max, we found it, which is 0.177 divided by L is 0.25, this is 0.5, half of it, 0.25 squared plus x max again 0.177 squared to the power of 3 by 2. Solve it, you'll get 0.044 Newton per Coulomb. Okay, actually this question appeared in Edexcel past paper unit 4, June 2014 paper, June 2014, WPH 04 paper, and this is the question 15. So in this question actually they did not ask to get this value, so they gave some other question, but it's the data given as a data. So there on part C they are saying that the question, the values, the diagrams are the same, but there the question they are saying that the maximum electric field strength is 0.044 Newton per Coulomb, and some other questions are asked beyond that. Those are normal simple questions. So normally when we are doing these questions, students normally ask how to get that value 0.044 is the maximum value. How do we know? That's a very common question students ask. So that's the reason I did it as a question here. So actually the data, this value was given as a data in the Edexcel paper, but I did it as a question here because this depends on calculus. Okay, I hope you understood. We'll meet on during another question, physics question based on mathematics.